Very good afternoon to one and all. Myself, Mehak Bhatia, Assistant Professor, IIMT College of Science and Technology, Greater Noida. Today, I am going to give a session on the features and structure of Java programming language. So let's begin with the lecture. Now, let's first discuss about what Java is, okay? Java is a programming language and a platform, okay? We all know that Java is a programming language. We have all heard about it. But Java is also a programming language and a platform itself. What is a programming language? A programming language is a computer language that is used by programmers or developers to communicate with computers. And what is a platform? A platform is any hardware or software environment in which the programs run. Okay, so a platform is basically any hardware or software environment in which the programs run. Since Java has a runtime environment, which is known as JRE, Java Runtime Environment, and API, it is also called a platform. So Java is both a programming language as well as a platform. Java is a high-level, robust, object-oriented, and secure programming language. We are going to discuss all these features of Java programming language in the coming slides. Okay. Now let us see a brief introduction or a brief history about how and when Java was developed. So Java was developed by Sun Microsoft, which is now a subsidiary of Oracle, in the year 1995. Okay, and we have been using Java since then. James Gosling is also known as the father of Java. Before Java, the name of Java programming language was Oak. So it was called Oak before Java. Since Oak was already a registered company, so James Gosling and his team had to change the name from Java to Oak. Okay, so Java was known as Oak, but later on, the name was changed from Oak to Java. Okay, this was a brief history about Java programming language. Now let us see what are the applications of Java. Now, according to Sun is the company's name, Sun Microsoft. 3 billion devices run Java. Okay, there are many devices where Java is currently used, and some of them are desktop applications such as Acrobat Reader, Media Player, antiviruses, etc. The second application of Java is web applications such as irctc.com. Okay, enterprise applications such as banking applications, mobile applications, embedded systems, smart cards, robotics, games, etc. So there are many applications of Java programming language. Now let us move to the main topic of this session, which is features of Java programming language. So we must know the features of any programming language before studying that language in detail. And the features of Java are very important as they are different from other programming languages such as C or C++. Okay, so these are the various features of Java programming language. Number one is platform independent. Second is object oriented, simple, secure, portable, distributed, multi-threaded, high performance, robust, interpreted, dynamic, and architectural neutral. Okay, these all are the features of Java which we are going to discuss in detail. Now let's begin with the very first feature of Java, which is platform independent. Now Java is a platform independent language. What does it mean? So the core philosophy of write once, run anywhere is the main core philosophy of Java programming language. Java is compiled into a platform independent form, which is called bytecode. Okay, so when we compile Java programs, they are converted into, the compiler converts the Java program into bytecode. Okay. And the bytecode can run on any machine which is interpreted by JVM, which is known as Java Virtual Machine. Okay. Write once, run anywhere. What does it mean? Java application generates a .class file that corresponds to our applications but contains the code in binary format. Okay. So whenever we run the Java or compile the Java program, it converts our program into .class file, okay, which has a binary format. And that class file can be run on any platform. Okay, so that is the reason Java specifically is known as platform independent, because that .class file can be run on any platform. Okay, here is a diagrammatic description of how the Java code is converted into bytecode and can be run on any platform. So whenever we write a Java program, we save the program with .java extension. Okay, so here our Java code .java with .java extension, when we compile that code, the Java compiler compiles it and converts it into bytecode, which is saved with .class extension. Now this bytecode, with the help of JVM, which is Java Virtual Machine, okay, can be run on any platform, any operating system, Windows, be it Linux or Mac. Okay, so this is a very important feature of Java programming language, that the bytecode is platform independent. It can be run on any platform. Okay, so it provides ease, that is architecturally neutral ease, as bytecode is not dependent on the machine architecture. Okay, it is the primary reason Java is used in enterprising IT industry globally worldwide. So this particular feature of Java programming language makes it very worldwide programming language. Okay. Now let's move on to the next feature, which is portable. Now Java code written on one machine can be run on any other machine. So we know the meaning of the word portable. Portability means it can be moved onto any system or any machine. So the code once written in Java can be run on any other machine. Okay. The platform independent feature of Java, in which its platform independent bytecode can be taken to any platform for execution, which makes Java portable. Okay, so the portability feature of Java is interrelated with the platform independent feature. Because Java is platform independent, it is portable also. Okay, so the Java code once written on one machine can be taken onto any other machine. That is the meaning of the word portability. Okay, now let's move on to the third feature of Java, which is interpreted. Okay, now what does the word interpreted means? Java is an interpreted programming language. So the programming languages use either a compiler or an interpreter. But Java programming language uses both compiler as well as an interpreter. Okay, Java programs are compiled to generate bytecode files, as we saw in the previous slide with the help of a diagram, that when we compile a Java program, a bytecode is generated. Then the JVM interprets the bytecode file during execution. So the Java files or the Java programs are compiled as well as interpreted. Okay, along with this, JVM also uses JIT compiler. It increases the speed of its execution. So Java is both compiled and interpreted. First, the compilation, with the help of compilation, Java programs are converted into bytecode files, and then with the help of JVM, the bytecode is interpreted during the execution. Okay. Now let's move on to the next feature, which is object-oriented. So we all know Java is object-oriented programming. Java has OOPS concepts. So it started as a language to overcome the limitations of C++. So Java was started to overcome the limitations of C++ programming language. It is purely object-oriented programming language. The object-oriented approach makes Java secure, reliable, and scalable. Now, what is object-oriented programming? We need to know that object-oriented programming is a paradigm of programming. The other commonly known paradigms of programming are functional programming, procedural programming, and task-oriented programming. So there are many types of programming. One is object-oriented. Object-oriented programming is based on objects, which contain data and methods, which are also called functions in some programming languages. It promotes modularity and reusability. So object-oriented programming basically is based on objects and classes, which contain different data and functions or methods. So what are the important features of object-oriented programming? Abstraction, inheritance, encapsulation, and polymorphism. All these terms are related with object-oriented programming, and Java covers all these features. Because Java is purely object-oriented programming language, it covers all the features of object-oriented programming also. So Java has abstraction also, inheritance also, encapsulation also, and polymorphism also. Now, the next feature after object-oriented is secure. Now, Java is a very secure language. Language before Java, such as C++, had a major drawback of security. It has features to ensure enterprise-level security in its applications. The features such as runtime checking, no use of pointers, exception handling, access control, and type checking are responsible to provide high security standards to Java. So there are many features which make Java a secure language. For example, we do not use pointers in Java. We use exception handling, which also provides security feature to Java. Type checking also provides security. So Java, as compared to other programming languages, is a very secure language. Now, next is simple. Now, what does simplicity means? Simplicity can be related with user friendliness. Okay, so the syntax of Java is very simple. Great readability due to the modular nature of the code. So the code is very modular in nature, and because of the modularity nature, it becomes very simple. It is easy for beginners to start off and understand the key principles of the language. Java syntax is based on C++, so it is easier for programmers to learn Java after learning C++. Java has removed many complicated and rarely used features, for example, explicit pointers and operator overloading. So in C++, operator overloading is there, but Java has removed it completely. There is no need to remove unreferenced objects because there is an automatic garbage collection feature in Java. So the automatic garbage collection feature helps a lot. It simplifies this programming language. Next is robust. So now, what do you mean by the word robust? Robust means strong or healthy, okay? So how can Java be a strong language? So Java is a robust programming language or a strong language for its strong features. So the strong features of Java makes Java a robust language, such as efficient memory management, automatic garbage collection, exception handling, and type checking. All these features make Java a robust language. These features make it the preferred language to develop huge enterprise applications with ease and reliability. Next is architectural neutral. Now, it has solved the binary distribution problem. It converts the code into binary code format that is independent of hardware architectures, operating system interfaces, and Windows system. So, what is architectural neutral? Architectural neutral means Java can be run on any architecture, any platform. This architectural neutral feature is correlated with the first feature, platform independent, that we discussed. Its runtime platforms are used for different hardwares and software environments. Any Java code written on any system configuration can run on any different system without the need to change the code. The format of bytecode format is system independent, making it architecturally neutral. So the system independent feature of bytecode format makes Java architecturally neutral. Okay. Java code can be compiled on one platform and executed on another platform without modification. So we can compile the code on one platform, and that compiled code can be executed on any other platform without modification or changes, which makes Java architecturally neutral. As we have seen in the previous slides, the Java code is compiled into bytecode, which is platform independent code that can be executed on any other platform that has JVM, which is Java Virtual Machine. So we can compile the code in one platform, which converts it into a bytecode, and that bytecode can be run on any other platform with the help of JVM. So the JVM interprets the bytecode and executes the Java program. This also makes Java well suited for distributed computing environments where different systems and environments may be used. So now this architectural neutral feature is also related with distributed feature of Java. So you can see with the help of diagram, the Java program is compiled with the help of Java compiler, which converts it into a Java bytecode. Now, this bytecode is platform independent. With the help of JVM, this Java bytecode is converted into a machine code, which can be run on any platform which will produce the output. So this is the architectural neutral feature of Java, which is related with another feature called distributed. Now, how is Java distributed? We can create distributed applications using the Java programming language. Remote method invocation and enterprise Java beans, EJB, are used for creating distributed applications in Java. So these are the two applications by which we can create distributed applications in Java. The Java programs can be easily distributed on one or more systems that are connected to each other through an internet connection. So which makes Java a distributed language. Now let's move on to another feature, very important feature, multi-threaded. Java is a multi-threaded programming language. Now, first of all, we need to know what is a thread. Thread is basically part of a process, okay, a sub-part of a process. Now, multi-threaded means multiple threads can run at the same time, simultaneously or parallelly at the same time, which will increase the efficiency of any system. It gives you the ability to run multiple processes or threads together to maximize the utilization of CPU. So multi-threaded feature maximizes the utilization of CPU, and Java allows multi-threading. Okay. These threads are run in parallel. Concurrently, they are run, and it is also known as concurrency in Java. As a developer, using the multi-threading feature of it, you can build interactive applications. Okay. Next feature is the dynamic feature or the flexibility feature of Java. Java, being completely object-oriented, gives us the flexibility to add classes, new methods to existing classes, and even create new classes through subclasses. Java even supports functions written on other languages such as C, C++, which are referred to as native methods. So which makes Java a very dynamic or a flexible language. Next feature is the high performance feature of Java. Java architecture is defined in such a way that it reduces overhead during the runtime, and at some times Java uses JIT compiler, just-in-time compiler, where the compiler compiles code on demand basis, where it only compiles those methods that are called, making applications to execute faster. It has just-in-time compilers that makes it faster and enable high performance. So the JIT compiler in Java makes the performance of Java high, or increases the performance of Java programming languages. It makes the execution of the code faster, which helps Java achieve the high performance feature. Now, these were all the features of Java programming language. Now, let's move on to the second part of this session, which is the structure of Java program. Okay, as you can see here, this is basically the structure of any Java programming, any Java program. First of all is the document section. Next is the package section. Then is the import statements. Next is the interface statements. Next is the class definition. And at last, main method class, which has a method definition. Okay. So we will discuss this structure of Java program. Now, first is the document section. Now, this is not a mandatory part of a Java program. It is suggested to use documentation section because it improves the readability of the program. Okay, it is not mandatory to use this section. It is just suggested because it improves the readability of the program. Next is the package statement, import statement, interface, and class definition. All these statements here are optional. Okay, you may use it or may not use it. Your program will run without these statements also. But to enhance the program, you can use these statements. Okay, we are going to discuss all these statements in the coming slides. And the last one is class with the main method. Now, this is essential or mandatory structure or part of the Java program. Without the main method class, you cannot run the Java program. Okay. Now, let's see what documentation section is. So the documentation section is an important section, but optional, as we have seen. It includes the basic information about Java program. Whatever we write in documentation section, the Java compiler completely ignores those statements during the execution of the program. To write the statements in the documentation section, we use comments. Okay, so all the comment part gets included in the documentation section. The comments may be single line or multi-line and documentation comments. Single line comments start with /. Multi-line comment starts with /, star, and ends with star and /. And you can write the multi-line comment between these two symbols. Okay. So documentation section was simple. It just includes the comments if you want to include them. Second is the package section. The package section declaration is also optional. It is placed just after the documentation section. In this section, we declare the package name in which the class is placed. There can be only one package statement in Java program. It must be defined before any class and interface declaration. It is necessary because a Java class can be placed in different packages and directories based on the module they are used. So we can use the keyword package to declare the package name. Next is the import statements. Now, the package contains many predefined classes and interfaces. So you can also write the package, complete package, or else you can just write the specific class that you want from that package. So if you want to import a specific class, you need to use the import statements. The import statement represents the class code in another package, and we can use import keyword to import the class. It is written before the class declaration and after the package statement. We use the import statements in two ways. Okay, we can either import a specific class or import all classes of a particular package. So if you want to just import a particular class, you can write it with the help of import statement, import keyword, import java.util.scanner. This is one example where you are just importing one particular class, scanner class. Or else you can import all the classes of a package with the help of star. So you can write import java.util.star. So what this statement is going to do, it is going to import all the classes of util package. Okay. So with the help of star, you can import all the classes of util package, or else you can just import one class by writing the name of that particular class. Next is the interface section. This is also optional. We can create an interface in this section. You can use interface keyword. An interface is slightly different from a class. It contains only constants and method declarations, no definitions. Okay, just declarations. Next is class definition. Now in this section, we define a class. It is vital part of Java program. Without the class, you cannot create a Java program. Okay, so a Java program may contain one or more class definitions, and you can define a class with the help of class keyword. A class is basically a blueprint of a Java program. It contains all the information of user-defined methods, variables, and constants. Okay, here is one example of a student class. You can write class keyword, name of the class, and define it in the brackets. Next is the main method class. In this section, we define the main method. Okay, this is very essential part of all the Java programs, because the execution of all Java programs start with the main method class. Okay, and in other words, it is the entry point of any class. So we have to write the main method class, and it must be inside any class. Inside the main method, we create objects and call the methods. We use the following statements to define the main method. Here you can see public class student, and inside it we are using the main class. Okay, public static void main. So inside the class definition, you can write the main method class. Okay. Here is a diagram of all the Java structures that we have discussed. The documentation section, the package statement, then comes the import statements, the interface section, the class definition, and inside the class definition, the main method definition. Is it okay? This is one more example of a Java structure. Okay, the comments is part of a documentation section. Then we have declared or defined a class, my program. And inside this class, we are writing the main method class, public static void main. Okay, and we can write the method body inside the main method class. And this is the header. Okay, so this was a brief introduction about the structure of the Java program. So in the today's session, we have discussed about the features of Java programming language and the structure of Java, basic structure of Java programming language. So that's all for today's session. Thank you.